hi YouTube, and welcome to a slightly different video from my normal game reviews. A little while ago I was at a client's site and I noticed that all the call center operators had little lights on their monitors, and these lights would change colour depending on what the call center operator was doing. So if they were busy it was red, if they were on the phone it was purple, and if they were free it was green. This actually seemed like a really good idea because we also use headsets in our office, and it's not uncommon when you're on the phone for someone not to realise you're on the phone and try talking to you. So I had a look at these devices online and found that they're nearly 80 New Zealand dollars each, and considering we'd need at least 7 of them for all the people in the office, I decided to see if I could make something a lot cheaper. So here's the result. This is just the prototype, as I'm going to get the scaled down parts from AliExpress, but this is a good way to test that all my software code works, and it does. So here's how it works. So we'll fire up the SkypeLite application, and the first thing it'll do is search all of the valid COM ports on your system to find the SkypeLite. This takes a couple of seconds, but it saves you having to manually select which COM port the SkypeLite is on. And as soon as it's found the COM port, it lights the SkypeLite up with your current status from Skype for Business, which in this case is off work or away. So once the SkypeLite application is running, you don't need to interact with it. You can just change your status in Skype for Business, and it will automatically update the colour of the SkypeLite's LED. So the yellow is a little bit greeny just because this is a tricolour LED, but it gives you the general idea. The main feature of this is to let people know when you're on the phone, so if we make a phone call, once the call connects you'll see the SkypeLite change to blue, which is quite unmistakable, so people know you're on the phone. Again, this is just the prototype. The production model will actually have a much bigger light than this. And when you hang up it goes back to green, or whatever your previous status was. And if you like, you can override the status directly in the SkypeLite application if you want to change the colour of the LED manually. So that's how the software works. Let's go a little bit into how the hardware and the code works that drives it. Once we take the cover off of the project box, we can see here the main Arduino Uno, which is driving the project. This one's just using the standard Uno because it was easy to get locally to get this one up and running, but the eventual product will use either the Uno Mini or the Uno Nano. So you can see at the bottom right hand corner of this the LED, which has got 3 pins for the colours and then 1 for ground. So I've used the correct coloured wires for those pins, so there's obviously a red wire for the red diode, a green wire for green, a blue wire for blue, and black for ground. The ground just plugs straight into the Arduino, whereas the other 3 wires connect through 330k resistors into the output pins of the Arduino. I've just used jumper wires and insulation tape just for this project, but the eventual one will be fully soldered together. So that's the inside of the hardware. Now let's have a little bit of a look at the code of the software to see how it works. The Arduino code is pretty straightforward. The first thing we do is initialize the pins. So we've got the green pin is on socket 8, the red pin of the diode is on socket 9, and the blue pin is on socket 10. Then we set up an incoming byte. So this is going to be where the information from the serial port goes into. We enable the serial port because this is how the C# software talks to the Arduino. Next we set all of the pins to be output pins, and then we sit and listen for data to come through the serial port. When data is available, we read that byte and then we handle it in this switch statement here. So the first byte we receive from the C# code should be byte 97, which is the handshake, so that the C# code knows that it's talking to the correct device on the other end of the serial port. If we get a 97, we send back an OK, and the C# code handles that, and we'll go into that in the next section. Then each LED color has its own byte code, so 48 is off, 49 is green, 50 is red, 51 is blue, etc, etc. So for off we turn all 3 pins off, for green we turn the green pin on and the other 2 pins off, and for things like the yellow we turn the green and the red on to make yellow, and the same for purple, we turn green off, we turn red on, and we turn blue on to make purple. This is the C# code which runs the main software that you see on your desktop when you open SkypeLite. The first thing that it'll do is try and find the SkypeLite and then pass those settings through to the main code. So what we're doing here is there is a feedback box on the main UI that lets the user know what the software is doing through each step so that they don't think that it's hung. So we let them know that it's looking for the SkypeLite. Then we start a new thread and we do the search for the serial port in that thread. And the reason we do that is so that it doesn't lock up the UI while it's looking for the serial port. So this is the event handler for that UI update. It's just in a wrapper because being in a separate thread it needs to invoke the control before it can put the text in. The main chunk of code here does the search for the serial port. So the first thing we do is grab a list of all the serial ports on the PC and put that into an array. And then we set a boolean, which we're going to refer to later, which is SkypeLite found, false in this case. So until this becomes true, the software doesn't know where the SkypeLite is. Next we go through each COM port in that list that we created up here, and we try and initialize those COM ports. If the COM port won't initialize for whatever reason, then that'll throw an exception, which is handled here, and you can see there's nothing in there. So we don't bother telling the user that there was nothing there, but we rerun that whole for loop on the next serial port. So in the interface you'll see here scanning and then the next port. If the port does initialize without any issues, we open it and we send a byte 97 or A in ASCII. Then we listen for an OK back. So as long as we get an OK, then we end this entire method. If we don't, then it goes again. If we do get an OK, then we set the SkypeLite found boolean to true. We let the user know that we found the SkypeLite, and we pass that serial port through to the main code. If all of this code is run and it's run out of serial ports to check and that boolean is still false, then we let the user know that we couldn't find the SkypeLite and perhaps it's not plugged in or there's an issue with the Arduino. This chunk of code here is where it has found the SkypeLite and it parses that serial port that it's initialized through to the main code here. So this is the main interface that you see with the ability to change the colors, and the first thing we're going to do is connect to the Skype for Business API. This is Microsoft still refer to the Skype for Business API as the Link API internally, so you'll see it referred to as Link in this code. So we try and create an event handler, so should the connected person's state change, then it will fire off a method which is called client state changed. If we couldn't create that event handler, that means that Skype's probably not running on your machine, so we throw an error to let the user know that, and then we exit. Providing that we could create that event handler, then we set up the serial port and we run update user interface, which we'll go into in a few moments. So the event handler listens for different changes in the Skype API. So should your name or your availability or any of your information change, it runs this method here, which is update user interface. Update user interface is a pretty straightforward method which picks up the details from Skype and then sets those in the UI, so it can set your name, your photo, and your availability. The main one that we're obviously concerned with here is availability. So should your availability change in Skype, this method will run. So once this method runs, it will grab your availability from Skype. It'll output it to the console just so we know that it's done it correctly. And then, providing that there wasn't an exception at this point, it will then take your availability and match it to this case statement here. So we have away, busy, busy idle, do not disturb, free, etc., etc. These case statements then fire the change LED color method, and each one is set to a color that matches that status. So away is yellow, busy is red, offline is off, and these ones here are the main ones that I'm concerned about, which is if you're in a call of any description, it goes blue. So that change LED color method is where most of the work of the software is done, which is this method here. And again, it's just a straightforward case statement. So we open the serial port, and then we change the color of the LED depending on the status that we got through Skype. So if we want to turn the light off, we send a 0 through the serial port, which the Arduino receives as byte number 48. And we also change the color on the UI to be, in this case, transparent. And then we do the same for green. We send byte 1, which in the Arduino code is byte 49. Remember, we're just changing from ASCII to bytes here, which is why it's 0, 1, 2, 3, 4 in the C# code and 97, 48, 49, 50, etc. in the Arduino code. So we're just sending bytes through the serial port and changing the UI color so the user can see what color the LED should be. And then the Arduino is taking those bytes and lighting the specific pins of the LED for those colors. There's a bit of a bug fix here that I had to do because sometimes the software would crash randomly, and I found out it was because I was trying to close the serial port before it had finished either transmitting or receiving data. So once it's changed the color, or once it's sent the command to the Arduino to change the color, it waits 500 milliseconds and then closes the serial port. So that's pretty much the code. There's a little bit of other stuff in here, which is where it gets your photo, for example. So it grabs that from the API as well, saves it as a PNG file, and then updates the UI to have that photo in it. And it also does the same for your name and other bits and pieces of your contact information. So that's the main code. So that's the SkypeLite in a nutshell, pretty much. Hopefully you've enjoyed this video. It's been a really fun project for me to do, and it has no real use as such. I was just curious as to whether I could build something cheaper than buying something, and in this case it proves that I can, because the actual busy lights are $80 each, and I worked out for about $10 I can build one of these SkypeLites. So you can work out the math from there. Hopefully you've enjoyed this video. It's been a little bit different. Thanks for watching, and I'll see you in the next video.